Welcome to Lesson 74, Identifying the Vertex. In this lesson, we have 4 criteria for success. 2 are going to be reviews from Lesson 73, and 2 will be newer, which spirals to some other skills we did in factoring. So let's start with the old. And with the old ones, we're going to identify the vertex of a graph as well as the vertex of a table. And that's going to be quick and easy for me to show from the last lesson. But here are newer ones. To identify the vertex from a vertex-form equation, we haven't talked about that yet, as well as identifying the vertex using completing the square, which we do know how to do, which will help change a standard form equation to a vertex-form equation. All right, let's start with the review parts first, looking at the graph as well as a table. So with a graph, it's pretty easy to identify. You're just trying to find that maximum or minimum point in the vertex. We can see it and just identify that point. So here it would just be 1, +6. In terms of a table, you're also looking for that turning point. So look here at your y values and identify where does that change happen. One visual I tend to look at is where my values start to repeat, and so that I know the change was right here at this exact point. That is my turning point, so that is my vertex. All right, so you can look for it in symmetry as well. So let's try to on your own. Let's look at this one first. Take a moment, 5 seconds, tell me, put it down on paper, what is the vertex? All right, 3, 2, 1. You should have said 1, -4, since we can clearly see it over here. Let's try on a table. Here's a table. Look at your y coordinates and identify which one of these coordinate pairs would represent your vertex. All right, 3, 2, 1, and I can see it right over here. Now, what was my clue? Here's where I'm seeing symmetry. So that's like that point there is really the line of symmetry. That's where it actually happens, where y is -2, and now all my points are changing around that. So my vertex is -1, -2. And we're going to talk about lines of symmetry on the line. Is it an actual point or is it an actual line? How do we represent that in a moment? So let's get into the new information, and that's going to be our vertex forms of our equations. Now, in terms of what vertex forms are, these are just equivalent. It's just another way of showing this quadratic. These are equal to each other, standard form and vertex form. And all you're doing to get from standard form to vertex form is just use completing the square to rewrite this. Why is helpful is because a vertex form helps us to find the vertex. Now I'll show you what I mean. We have this equation here, and I'm going to put it into decimal so we can see what it looks like for it, just to help us out. And we can clearly identify our vertex as 4, -17. So I'm going to put that there. And I want you to think in terms of looking between here and here, do you notice something that is the same about both of them? What do you see? What do you notice? Well, you probably noticed the -17 and the -17 here. So those values are identical to each other. And the other part you notice that look very similar is here I have a 4 and here I have a 4. So we're going to talk about that in just a sec. So what I'm going to do is I'm going to just superimpose. I'm going to put the standard form here, y equals ax minus h squared plus k. And what I'm going to tell you is that h is going to tell you how to shift your parabola to the left or to the right. It's that horizontal shift. So if this was just a regular x squared, we'd have it over here. And that h is telling us I'm shifting 4 to the right to get to that +4. Now, that's weird because we're used to, when we have a negative number, we're used to negative numbers moving us to the left. So this is a case where if it's a positive number, it's going to shift us to the right. And if it's a negative number, it's going to shift us to the left. So I'm giving you that so you can be aware of it, because it's it's like counterintuitive to everything we've done. And that k is going to be our vertical movement, as that up or down. And so if it's positive, we're going to shift up, and if it's negative, we're going to shift down. And in this case, we have negative 17, so we went down 17. And that got us to our new coordinates for negative 17. So when we get an equation in this form, what we can do is you're going to write the equation right on top, literally right on top. And you're going to identify the a, in this case was just 1, our h, and this is how I cognitively think about it. I see a negative 4, so that means I'm going to go right 4. So I have to write that down to myself so I know what that coordinate is going to be. And here's our k, is just negative 17, so again I'm going down 17, and that's what helps me write down my coordinates. All right, hit pause and jot this down into your notes. Let's do one more very quickly as model. So here's our equation, y equals parentheses x plus 3 squared plus 20. So the first thing we're going to do is just recognize this equation is written in vertex form. So we need to identify a, which is 1, our h, which is 3. So negative h tells us I'm going to go to the left 3 times. And k, which is positive 20, so I'm going to go up 20. This means our vertex is negative 3, 20. And we can confirm it on our graph, just putting it onto Desmos, same exact formula. You can see that is, in fact, the vertex. So once again, you can see how I can very quickly take the vertex form of the equation and find the vertex as long as I know what h and k are. Hit pause and jot this into your notes. All right, here's our final drop mic moment. I'm going to take this equation from standard form and move it to vertex form, because in our question here, they're asking us to complete the square to determine the vertex. So watch how I do that. And that's going to be my how. Okay, we've done this before. So x squared minus 14x minus 15. I'm going to set this at x squared minus 14x is equal to positive 15. That was my only shift. Remember, you're halving 14 and then squaring it. So that would be negative 7 and then squaring it. So you get positive 49. I'm doing the same thing to the other side, positive 49. So that's all we've done is to just complete the square so far, and that's great because now I can rewrite this as, instead of x squared, x minus 7 squared is equal to 64. And I like that because now I can just move that 64 back over and I have something written in vertex form. That's what we wanted. All right, so that's our first point. So hit pause and jot this down into your notes. Now we can work with this. Okay, so since we're at this point, let's write our regular vertex form, which is a x minus h squared plus k, and we have y is equal to x minus 7 squared minus 64. So in this case, a is equal to 1. Our h, what's happening with our h? We have a negative h, so that means we're going to go to the right 7. All right, so h is equal to 7, and our k is a negative 64, so we're going to go down 64, negative 64. So that makes our vertex 7, negative 64. Okay, this is our hotspot. Our hotspot is always at 8. So remember, if it's a positive 7, we're moving to the left, to the left. If it's a negative 7, to the right, to the right. So hit pause, jot this down into your notes. And just for confirmation, the vertex 7, negative 64, let's look at it. And there you have it. There's our equation written in Desmos. There's our vertex 7, negative 64. So this does work as a visual. So there you have it. We've connected a ton of dots, and this is going to take practice. That's a lot of information to internalize, and to synthesize in our brains. But we'll get some practice in. But now you will know how to identify the vertex of graphs, tables, and an equation, whether it's written in standard form or vertex form. That's it for today's lesson, Math Marbles. Feel free to use this and watch this as many times as you need to, and use your criteria for success as always to advocate and get the feedback you need to master today's skill, because it absolutely is possible. That's it for today. I'll see you in the next one. Be well.